All right, continuing on with this problem. So far, we've graphed one segment of this red function, of the sine function, as a domain of negative pi over 2 to pi over 2 to make it 1 to 1. The range of this segment of the sine function is negative 1 to 1. Now, we're going to graph the purple function, which will be our sine inverse. So we're going to take these ordered pairs and graph them. Notice that the range and the domain are inverses of each other also. What we're getting out now is angles. So what we started with over here, with as our domain as angles, and what we got out were values. Now we're plugging in numbers and we're getting out angles. They're the opposite of each other. Okay, so let's go ahead and graph it. So our x-axes are now going to be numbers, not angles. So I'll just say this is 0, 0. Again, these are not equal. So we have 1/2, square root of 2 over 2, square root of 3 over 2, and then 1, and then go back into the negative. And then angles. Here's pi over 6, pi over 3, or pi over 4, pi over 3, pi over 2. And then you go down to the negative. All right. Now let's graph them. So first one is 0, 0. Next one is over 1/2, up pi over 6. Next one is over pi over 2, or over square root of 2 over 2, up pi over 4, over square root of 3 over 2, up pi over 3, over 1, up pi over 2. So there are some ordered pairs graphed out. We can continue that. So it looks like such. The domain of this inverse function is the opposite of this domain in range. So the domain, the x values for this sine inverse function is from negative 1 to 1. And then the range are your angles, starting down here at negative pi over 2 and leading up to pi over 2. So that's what your graph should look like for y equals the sine inverse of x. There's another name for the sine inverse function that you need to recognize. Textbooks use it. Or y equals the arc sine of x. So please make sure you know both words. You'll see that on your assignment. Sine inverse of x or arc sine. They're asking for the same thing. What we're going to do in just a few minutes is we're going to now evaluate the sine inverse function. We're going to plug numbers in and see what we get out. Notice again, when we were over here in our t-chart, what we're going to get out is angles when we evaluate the sine inverse function. When we evaluate the sine function, we're getting values out. Total opposite. They're inverses of each other. But there is some restrictions on its domain and range that we have to take into consideration. We don't have to do that for the parent function of the sine of x. So here's just some overall view of what we just did. So you don't have to write this down. So first what we did is we just focused on the parent of y equals the sine of x. Then we took out a piece from the original sine function to make it 1 to 1, to pass the horizontal line test. So that's this piece right here graphed out. Then what we did is we took each of those individual ordered pairs and we interchanged them. So now it looks like this. So this is your y equals the sine inverse of x. That's what we've done so far in this lesson. We start off the original sine function, we cut it down to one section to make it one-to-one, and then we interchanged all the ordered pairs. All right. So this is just kind of what it looks like, a little prettier view that we had done in the purple when you finished your last example, or your last set of notes. All right. Here's a nice pretty picture from your textbook doing the same thing. You don't have to write this down. We've already done it. They just listed out all the nice pretty, some ordered pairs and graphed out the sine inverse function. Okay? All right. Here's what you're going to see in your assignment. So go ahead and write this down. If possible, find the exact value without the use of technology, no calculators. Evaluate the arc sine of -1/2. This is also saying sine inverse of -1/2. What does it equal? That's the other way you could say that, by the way. Okay, so we want to find out what it is. And if you read it says, if possible. Not every time can you evaluate any random number for a sine function, for a sine inverse function. So let's talk about the domain. What type of numbers could you plug in for x into the domain? What could go into here? Do you remember what the domain was for the sine inverse or the arc sine function? Let's go back and look. Down here in the purple. Domain can be -1/1. And what can it get out? -π/2 to π/2. Angles. So we're going to look at our unit circle. And we're going to try and find -1/2 on the unit circle. So where do you see -1/2 for the y value? Right here. Here's -π/2. So the sine inverse of -1/2 is the angle, -π/6. So that's our answer, -π/6. Or -30 degrees. Each of those answers is fine. What I want you to do on your assignments is to tell me the exact value in radian measure. You can check your solutions if you want to with your calculators. I would recommend that you check it in degree mode. All right. Here's another one. If possible, find the exact value for the sine inverse of square root of 3/2. So first check, is it in the appropriate domain? Is square root of 3/2 in the appropriate domain? Is it between -1 and 1? Yes. So now we look and try and find on the unit circle square root of 3/2. And then what is that angle measurement? Here we are. Back at this. We had some fun with it. You find square root of 3/2. There it is. There is square root of 3/2. So what's the angle? π/3. Again, we're not looking at these other two quadrants that don't exist for our sine inverse. So our answer then is π/3. Or 60 degrees. One more of these. If possible, find the exact value of the sine inverse of 2. Is it possible? No, it's not possible. The reason why it's not possible is it's not in the appropriate domain restriction. The domain must be between -1 and 1. And this is 2. So you cannot evaluate this sine inverse function.